All right, before we go any further, we need to pause for a moment. So far, we've been talking about machine learning in plain English: data, models, patterns, predictions. And that's been enough to get the big picture. But from here on, things get a little deeper. To really understand what's happening inside an AI model, we need to peek at the language it actually thinks in. That language is math. In the world of AI, almost everything eventually becomes numbers. Images become numbers. Words become numbers. Sound becomes numbers. Even intelligence itself is represented through math. Now don't worry, this isn't going to be heavy math. No formulas to memorize, no long calculations. Just enough to understand what's happening underneath. And we'll only learn each idea when we actually need it. The math behind AI usually comes down to four big pillars. Linear algebra, the math of vectors and matrices. How we organize numbers so a model can work with them all at once. Calculus, the math of change. How one thing moves when another moves. This is what helps a model figure out how to improve itself. Probability, the math of uncertainty. Because in the real world, nothing is ever 100% sure. And optimization, the math of getting better. How a model slowly fine-tunes itself until it actually performs well. Together, these four pillars are the foundation almost every AI system stands on. We'll meet each one in time, but to start, we'll begin with the first, linear algebra. Let's start with the simplest relationship you can imagine, a straight line. Think about everyday patterns. The more time you spend on screens, the higher your stress. The bigger the house, the higher the price. These are simple, predictable patterns. And in math, we describe them with one tiny, famous equation. Y equals mx plus b. X is the input, the variable you control, whatever you feed in. M is the weight, how steeply y rises as x increases. B is the bias, a constant offset where the line starts. One input, one output, a single straight line. And watch what happens as we adjust M. A bigger weight, the line gets steeper. A smaller one, it flattens out. In simple terms, the weight is just rise over run. How much the output changes when the input changes. And that single number captures the entire relationship. Here's why this matters for AI. Every time a machine learning model trains, it's adjusting weights like this, tweaking them, tuning them, finding the weights that best match the pattern in the data. So even though y equals mx plus b looks like something from a school textbook, this is really where modern AI begins. But in the real world, one input is rarely enough. In the real world, outputs depend on many things. Take house prices. The price doesn't depend on size alone. It depends on the number of bedrooms, the distance from the city, the age of the building, and a dozen other factors. So instead of one input, we have many. Each row in this table is a house. Each column is an input, a feature. A real model might have hundreds of these features, thousands, sometimes millions. And just like before, each input gets its own weight, its own little say in the final answer. So our equation grows. Y equals the sum of every input multiplied by its weight, plus the bias. But written this way, the equation is a mess, a long row of letters and numbers, hard to read, hard to think about. So mathematicians came up with a much cleaner way to write it, the matrix form. Instead of listing every input and every weight one by one, we bundle them into groups. All the weights line up in a row. That's our weight vector, W. All the inputs stack into a column, the input vector, X. Multiply them together, add the bias, B, and the whole long equation collapses into something small and neat. Y equals W times X plus B. One compact line, and it does the work of all those additions. And here's the real power of writing it this way. Look at the table. Rows for each house, columns for each feature. It looks like a spreadsheet, but it's really just numbers arranged in a grid. And in linear algebra, that grid has a name, a matrix. So our entire dataset becomes a single matrix. Every house, every feature, all in one neat structure. And now, instead of running the equation one row at a time, we feed in the whole matrix at once. Y equals X times W plus B. And that one line? It's everywhere in AI. Neural networks use it. Recommendation systems use it. Language models use it. Billions of times every second. Every time an AI predicts something, recommends something, recognizes a face, generates an image, writes a sentence, underneath all the fancy layers, the same simple idea is running over and over.